Alrighty guys, Mrs. Ackland here. We are taking a look at IXL area of equilateral triangles and regular hexagons. And I am going to show you guys two different ways to solve these problems. The main way that I like to solve them is using a compound area method, but IXL, if you click on Learn with an Example, they are going to show you something called the apothem formula. Okay, so I'll show you guys the apothem formula in a little bit, but I want to start by just showing you the compound area method, and this is how I would do this problem right here. It says an equilateral triangle with center B is shown below. What is the area of the triangle? And we know that the area, or the formula for the area of a triangle, is just 1/2 times the base of the triangle times the height of the triangle. And so if we were to just take a look at this problem and start to approach it in this way, we would quickly run into trouble because we know the base of the triangle right here, 4 square root of 3. This is an equilateral triangle, so all 3 of the sides are 4 square root of 3. We could even copy this all the way around if we want. Okay, so the base of the triangle is 4 square root of 3, but we don't know what the height is, okay? If you were to kind of rotate this triangle, you could say that the height is this distance right here, but we don't know what it is. This bit right here from B out to this side right here is equal to 2, but this whole thing, it's not 4, and we don't know exactly what it is. But what we can do, I'm going to erase a little bit of what I just marked on here, is we can, there we go, I erased all of it. We can take this triangle, it's an equilateral triangle, and we can break it up into smaller triangles. And of course, my lines here aren't going to be super perfect, but if you would take and draw segments from the center out to each vertex of this equilateral triangle, basically what you've done here is you split it into 3 smaller triangles. So now we could find the area of this triangle right here that I'm shading in, right? Couldn't we? This whole thing, this whole triangle right here. We can use our 1/2 base times height to find the area. We know the base is 4 square root of 3 because it's the same side all the way around, 4 square root of 3. And we know the height of this little triangle. The height is going to be 2. Okay, so in a moment, I'm going to grab my Desmos calculator and I'm going to type in this. I'm going to type in 1/2 times the base, which is 4 square root of 3, times the height, which is equal to 2. That is going to give me the area of this triangle. And then to find the area of the entire equilateral triangle, we're just going to take that and multiply it by 3 because there are 3 of these little triangles inside the whole thing. Okay, so let's pop over to our calculator. 1/2 times 4 square root of 3 times 2 times 3. So 1/2 times 4 square root of 3 times 2 times 3. 2 times 3 is equal to 20.78. And let's come back over. They want us to round to the nearest tenth. So our answer is going to be 20.7. Let's look at the next digit over, which is an 8. So that's going to round 20.7 up to 20.8. Okay, so just to kind of go over the process with you again, we're taking this regular polygon. A regular polygon is any polygon where all the sides are the same length. So we're going to have some equilateral triangles and we're going to have some regular hexagons as well. We break it up into smaller triangles by drawing segments from the center out to each of the corners or the vertices. And then we find the areas of those little triangles. Once we have that area, for triangles, we're going to multiply by 3, and for hexagons, we're going to multiply by 6. All right, let's go ahead and submit this, and we'll try one more. Okay, so this is another triangle. I'm going to start by splitting this equilateral triangle into smaller triangles. I'm going to draw from the center out to each vertex. I know my lines are not perfectly straight, but they're good enough. And then I'm going to find the area of this triangle down here. So my base is 2 square root of 3, and my height is 1. So that'll be 1/2 base times height. So 1/2 base, which is 2 square root of 3, times height, which is 1, times 3, because this is a triangle. So there are going to be 3 of these small triangles in this larger equilateral triangle. So 1/2 times 2 square root of 3 times 1 times 3. Let's go do it. So 1/2 times, I forgot already, 2 square root of 3, 2 square root of 3 times 1 times 3, I think is what it was. And here's our answer. The answer is 5.1, and then we look next door to the 9 that tells us to round up. So 5.1 is going to become 5.2. And we will submit. Okay, awesome. So for this one, let's take a look at what we have. It says an equilateral triangle with center C is shown below. Find the area of the equilateral triangle. For this one, I'm going to keep going with the same method. I think I'll show you guys an apothem method maybe on the next, like on the first hexagon one that we get maybe. For this one, I'm going to start the same way that we've started before. And we are going to draw our lines from the centers out to the edge. Start to get set up. We want 1/2 base times height. But I'm running into trouble here because I do not know the base of this triangle. I know the height. The height is 3. Okay? But I don't know what the base is. So this is interesting. I mean, there's a couple of ways that you could figure out the base. One way would be to take this even littler triangle, right? So we've taken our equilateral triangle and we've split it up into 3 smaller triangles. And then if we took each of those small triangles and broke them up in half again, you've got this little triangle right here. And it's a right triangle, so you could use the Pythagorean theorem to figure out what this missing side is. Okay, so you could do the square root of 6 squared minus 3 squared to get this side right here. But another way that we could do this is we could notice, or we could realize, that this little triangle is a 30, 60, 90 triangle. It's a special right triangle. How do I know that? Well, this whole thing is an equilateral. So in an equilateral triangle, all the angles are 60 degrees. So this whole angle right here is 60. So that means that this little angle right here is 30. I'm going to try to write 30 right there really small. That's 90, so this has to be 60. Okay, and let's look at the sides that we know. We know the short leg, we know the hypotenuse, and look at that, the short leg times 2 gives us the hypotenuse. That's what we know about 30, 60, 90 triangles. And then can you remember how we get the long leg from the short leg? Okay, so the long leg is going to be the short leg times the square root of 3. So the long leg is 3 square root of 3. Okay, that is this little distance right here. And then if we want the whole base of this triangle, remember that's what we're trying to find is the base, you would just multiply that times 2. So 3 square root of 3 times 2 is just 6 square root of 3. And that is what the base is. So this problem was definitely a little bit trickier because we had to figure out the base either using the Pythagorean theorem or using special right triangles. Okay, now this whole expression right here, 1/2 times base times height, is the area of this triangle. To find the area of the whole thing, of course, we're going to have to take that and multiply it by 3. So let's go do it. So 1/2 times 6 square root of 3, 1/2 times, times 6 square root of 3 times 3 times 3. 3 times 3 gives us 46.7. Look at the number next door. It's a 6, so that rounds up. So 46.7 becomes 46.8. And we'll go ahead and submit that one. Okay, cool. So we have a regular hexagon problem, and I am going to show you guys the apothem method for this one. You can use the apothem method for any of them. So let's start with the apothem itself. The apothem is the distance from the center of any regular polygon out to the midpoint of one of its sides. Okay, so this 3 right here, that is the apothem. And in the apothem formula, we just use a lowercase a. Okay, So what is this formula? The formula says that the area of a regular polygon is equal to 1/2 PA, capital P, lowercase a. We just said that the lowercase a is this apothem, which is 3. The big P is the perimeter. The perimeter is the distance all the way around this thing, okay? Well, we know that one side is 2 square root of 3. This is a hexagon, so it's a 6-sided figure. So if we take 2 square root of 3 and multiply it by 6, that is going to give us the perimeter. Okay, because there's 6 sides here. So let's start to put this together. So our area is going to be 1/2 times the perimeter, and we just said that the perimeter is 2 square root of 3 times 6. So 2 square root of 3 times 6. Okay, times the apothem, and the apothem is 3. So I don't know, was this easier? Maybe it is, maybe it isn't. Let's go ahead and plug this in. So 1/2 times 2 square root of 3. Oops. Times 6 times 3. And that gives us 31.1. Look at the next number over. It's a 7. That tells us to round up. 31.1 becomes 31.2. Okay, so this is a hexagon problem, and we use the apothem method. We could have used the compound area method for this. Hopefully we'll get another hexagon problem, and I'll show you that on the next page. All right, so this is our formula using the apothem method. If you get any of these wrong or ask for like feedback or ask to look at the example in IXL, they are going to show you this apothem method. So that's why I wanted to be sure to show you that. Okay, another equilateral triangle. Maybe we'll use apothem for this. Okay, so it's equal to, area is equal to 1/2 PA. Might as well, right? We'll do practice with both of them. So 1/2 times the perimeter. So the perimeter is this distance here, 8 square root of 3, multiplied by 3 because there's 3 sides. So the perimeter is 8 square root of 3. Maybe I like this method better. I don't know. I like them both. I feel like the other method is more intuitive, but this one might be a little faster. Times A. A is the apothem. The apothem is 4. Let's pop that into the calculator. 1/2, whoops, 1/2 times 8 square root of 3 times 3 times 4 gives us 83.1. The next number over is a 3 this time, which is small. It's 4 or fewer, or 4 or less, so we do not round up. So we just keep it at 83.1. So 83.1 is going to be correct. All right. Well, this video can only be 15 minutes long. I don't know if I have time to do one more example, but I feel like you guys got a lot of good examples from this. So regardless of the method that you use, whether you split your figure up into small triangles, I can maybe show you that with this one real quick. So you would take this and split it up into little triangles, find the area of one of those triangles using 1/2 base times height, and then multiplying that number times 6 in this case because it's a hexagon. That would be one method. Or if you use your apothem formula, which is 1/2 times the perimeter times the apothem, you are going to end up with the correct answer either way. Sometimes it gets a little bit tricky because they do not give you your base, right? Or they don't give you the number that you need to find the perimeter. Sometimes they'll give you this, like the hypotenuse of a little triangle right here. And if that happens, you are going to have to either use the Pythagorean theorem or 30, 60, 90 special right triangles to come up with the base. I feel like that's like maybe the trickiest scenario here. Anyway, good luck. Let me know if you have any questions.